going to start with multiplication of radicals. Starting with multiplication of radicals, let's see. Remember when we simplified radicals, we said, hang on a second, I've got to get a pen here. If we simplified radicals, we said that square root of AB equals square root of A times square root of B. We used the idea of square root of 8 equals square root of 4 times square root of 2 equals 2 square root of 2. And we separated our product into factors. And we knew that the factor, what we tried to do was rewrite our 8 as a perfect square times something else, and that perfect square got to come outside the house. Well, sometimes what we want to do is if we're multiplying stuff, we can use this rule backwards. Use that rule backwards, because this rule really says that we can go either way with that direction arrow. It's kind of like Michael Jordan when he was driving to the lane. He could go either way. Or I guess LeBron James. I'll update my basketball reference. Go to the left, go to the right. Same thing here. Now, before when we separated and conquered, we could go this way. Now, when we combine and conquer, we're going to multiply these things together to get our product inside the house. So the whole idea is if we're multiplying our radicals, now we can say, now let's combine these and conquer. This would be square root of 3 times 2, because square root of 3 times square root of 2, it's kind of tedious. We can rewrite that as something simpler. That's a little more helpful. So we use this rule and combine and conquer. 3 times 2 is 6. Done. Square root of 6 is the same as square root of 3 times square root of 2, but it's written in a more condensed fashion. And now we can just make things a little bit more complicated. All we're doing is now saying instead of just having the square root of 3 times the square root of 15, we can say, let's have a number outside. But now we just pay attention to what's outside and what's inside. What's outside the house? In fact, we could rewrite this probably as 5 times 2 times square root of 3 times square root of 15. Because all this stuff is multiplied together. These are all individual factors. We can just choose to rewrite these factors here as 5 times 2 outside the house. So now what's outside the house? 5 times 2, 10. What's inside the house? Square root of 3 times 15, 45. Done? Not quite yet, because now when we combine these guys, sometimes we got to pay attention to the fact that maybe we can simplify this. 10 square root of 45 is, can we rewrite 45 as a perfect square times something else? Yes. 10 square root of 9 times square root of 5. 10 times square root of 9 is 3 times square root of 5 is 30 square root 5, which is a lot easier to write than all this stuff up here, and even easier to write than this, because 45 is pretty darn big. Alright, but what about this? Same idea holds true here. You know what? I got 6a times square root of ab times all this stuff here. Yikes. Let's see. Well, what we can do is, just like over here, multiply what's outside the house first. Multiply what's outside, the coefficients first. 6 times 1/3. 6 times 1/3 is 6 over 1 times 1 over 3. 6 and 3 cancel out to give me just 2 over 1, or 6 over 3, which is just 2. Number there is just 2. A times a outside the house is a squared. Square root of ab times square root of a is square root of a times a squared. B, rats, this a squared needs to be simplified. Alright, I got a 2a squared still outside the house. Square root of a squared, square root b. Square root of a squared is a, and all this other stuff can't be simplified. It's already simplified pretty much as it is. 2a squared times a times square root of b, that's a b. Simplify and kind of combine everything that's outside the house. 2a squared times a, 2a cubed times square root b. I'm just squeezing it in there. And there's my answer. Alright. Take a look at this one. What is that one? Square root of 2 times square root of 5. Square root of 2 times 5. Square root 10. Done. And these a and 1 parallel one another. B and 2 parallel one another. C and 3 parallel one another. In other words, they're kind of the same idea, but just different questions. All right, question number 2. I'll put it in green to be consistent. Negative times a negative, negative times a positive, negative 5 times 4, 20. And again, multiply everything outside the house first. Z times z, z squared. Inside the house, square root of 6 times 2, 12. Done? Not quite yet. 12 could be simplified. Negative 20 z squared times square root 4 square root 3. Negative 20 z squared times 2 times square root 3 gives me an answer of, I'll extend the page here, negative 20 times 2, negative 40 z squared square root 3, still inside the house. Combine everything outside the house by multiplying, because it's all multiplication. All this is multiplication, so we keep the multiplication all the way down through here. Multiply everything outside the house. Inside the house stays as it is. All right, number 3. 9 times 1/3. 1/3 of 9. 9 divided by 3 is 3. We're, again, combining things outside the house by multiplying, because this is all multiplication. 9 times 1/3, 3. Y times y outside the house, y squared. Inside the house, square root of x times xy is square root of x times y. X times y. 3y squared, square root x squared y. Everything gets its own house. 3y squared, square root of x squared, square root y. 3y squared, square root of x squared, square root of a perfect square means the base comes outside the house, times x, square root y. Let's combine everything, make it prettier. This could be an answer because everything's outside the house. But usually we put the variables in alphabetical order. So 3xy squared is prettier, more elegant, I guess, as an answer. And there's our answer.